Okay, today we're going to talk about is taking a CRT television that's portable, like this one right here, and turn it to a oscilloscope. It's very easy to do. It's not that hard. Anyway, what you got, those wires that go to the coil at the back of the tube. The back of the tube has coils on it, and it works exactly similar as a regular CRT scope, and except instead of using plates, it uses coils. I think that's because of the precision. These CRT scopes you find that use tubes on the CRT tube scope, the analog ones, they use plates on there is because it's it's probably uh it's probably because it's more precision and more accurate than it would be with the coils. Coils are just easier because you don't have to worry about doing it with plates. Just gotta wire them up, and the magnetic field attracts the beam. I already cut all the wires except for all 4 wires off there. So if you turn this thing on, you should see a dot in the middle of the screen. You see a dot in the middle of the screen, that's a good sign that you just cut the right wires. Turns on, I got static on to let you know it turned on. There's a dot right there, as you can see it's in the middle of the screen. Then I also wired up a switch here because I don't have all the parts just yet for it. So what I got the switch here for is it's going to a 5-volt USB battery, and what it's going to do is it's going to simulate uh, the signal pulling the dot, moving the dot up and down. It'll go from here to here when I flip the switch. As you see, it did. And if I did the other coils, the other coil, it would go from here to there, and there to there. And if I reverse this, I'm going to see if I can try to reverse this. Hang on a second. All this. 1 second, please. Alright. I'll put some pop. I'll click it to you. This right here. We'll go to the next section, which is if I hit switch, and the wire can loose. Wires don't want to hold in there pretty well. Did I do it on the right one? I think I did. Maybe this will make contact. Oh, I see. It's working. Just the resistance is different. That's another thing about these scopes here. As you see, it's not going that far that way as it did down this way. It did down well down earlier. But if you see it going left and right, as you see here, as I couldn't get to touch the wire again. Right? Hang on, I'm going to twist it around there. And then you can see it going left and right now, I think. You can see it not going very far, unlike the other way. And if I were to reverse the polarity, take this here and swap it, it'll go the other direction because that's going opposite polarity. Now the black part is right off. Yeah, see, now it's going the other direction, as you can see. Now, I'm going to turn this off and talk more about it. Now, in order to get it where it displays the actual waveform on there, like like a sine wave, like this, or anything like that, you have to have a sawtooth or triangle wave generator, or something called a time-based generator, because it generates time from the generates a signal for the timing. It's hard to explain how it works, but I know how it works. I played one time I was making one. I was playing around with a whole bunch of different signals and found this one that had that took almost every single signal I had and barred it up into the picture on the tube on the screen. In fact, it wasn't even triangle, it was triangle. Because the function generator I had at that time only do sine, square, and triangle. It can do triangle, but it might not be that accurate. Also, I didn't use push pull on that one on the time based one. I just used a single transistor. It's all right if you don't want to. It's all right because it doesn't really have to go negative. And that's how I'm going to do it. And sooner or later, I'm going to have the parts that come in that will be for finishing this up and making it where we can actually measure signal, not just have a dot that moves left, right, up, and down. Actually measure signals and stuff. This is just a concept of that dot. See what happens is on oscilloscopes, the dot will move up, down, left, right so fast that your eyes will think that it's making a line, but it's not. It's a dot going so fast. It's shown. It's shown like it's always in those certain spots. And that's how it works. Well, we'll have to wait to see when that comes out. So thanks for watching. If you like it, I think this is going to work.